Alright, we're on day 2. We're talking about a polynomial function. Basically, polynomial function has the form f of x is equal to some constant x to the n, and then it keeps going down in descending order. We've seen that when we've written out our quadratics or linear. We always have x squared, then x, then the number. Okay, but now we're going to start talking about things bigger than x squared in this chapter. So first of all, degree of 0, we call this a constant because there is no variable. So if I have a degree of 0, it's a constant, and the form is f of x is equal to just that constant a sub 0. Okay, remember a is like just a number. And they are real numbers, and they're whole number, or they're real numbers. So linear. If you have 1 degree, you have a linear function, a linear polynomial. So f of x is equal to a sub 1 times x to the first plus a sub 0. Almost looks like a 9. Alright. Now 2, we've talked about these. If you have an x squared, what type of problem is that? We dealt with that all last chapter. They are called quadratic. So we have f of x equals the coefficient for the x squared, the coefficient for the x, and then the constant coefficient. 3. If you have a degree of 3, we call that a cubic function. And you guys should be able to write out the forms: a cubed, x cubed. I shouldn't say a cubed. A sub 3, which means the coefficient for x cubed. A sub 2, which is the coefficient for x squared. And so on and so forth. Now, the other 2. If you have a power of 4, it's called a quartic. And if you have a power of 5, it's a quintic. And you can write these out, and they basically follow the same pattern. But again, remember, descending order is key. So your x to the 4th term should be there first. It's a lot to write out. But you get the idea, you see the pattern, and so on and so forth. I just have to get these down. And done. Okay, so that is the format of these polynomial functions. It's important to know the name and understand them, but you know basically the first 3. Constant, linear, quadratic, cubic you should be familiar with, and then quartic and quintic. So, alright, identifying. Here's the thing. It's not polynomial unless all the exponents are whole numbers, so no fractional exponents or no negative. No negative or fractional exponents. All coefficients are real numbers. We don't have any imaginary coefficients. So right here, number 1, decide whether it is a polynomial function. If it is, write it in standard form. State its degree, type, and leading coefficient. Alright, right away. Number 1, I see I have a negative exponent. That's no exponent, not a whole number. Okay. I look at letter B. My exponents look fine. My coefficients are real numbers. So yes, so I have to write this in descending order. This is a polynomial function, and the correct order would be x to the 4th minus 0.8x cubed minus 5. I look at the degree. Degree is 4 because the highest power is 4. The type then would be quartic, and the leading coefficient is the coefficient of the front x value, so of the x to the 4th. And the number in front of x to the 4th is 1 because there's nothing there. So these are my answers for letter B. Alright, now Evaluating a polynomial function. We've done this before with quadratics and with linear. Put it into your calculator as an expression, so you can just type it in. There's 4 ways to do it. Just type it into your calculator. Use the function notation. Put it into y1 and trace on the graph, or use the table. Put in y1 and set your table to ask. So there's a bunch of different ways to do it. I like to focus on this one usually because it's just easier. So it says evaluate this function for x equals -2. Now one way you can do it is just say when x is -2, you write it out. 3 times -2 to the 5th minus -2 to the 4th minus 5 times -2 plus 10, and solve that. However, if you are scared about doing it that way, or you're worried about these negative signs, again, I'll show you how to do that on the calculator. Let's plug this in as our y1. So I have 3x, and then to the 5th you do caret 5 minus x to the 4th, x caret 4 minus 5x, and plus 10. And again, if I'm going too fast, you can always pause your video. So I have that in my y1. You don't have to graph this. I'm going to hit second mode to get back to the home screen now. And remember, you go to vars, move over to yvars, hit enter on function, hit enter on y1. I want to know what y1 is when x is -2. And you hit enter and you get -92. That should be your answer. That should be your answer. So so my function when x is -2 is -92. Okay. So you could also look at the table for that. You know, if you had the table you wanted to look at, like second table, and you go to x is -2, and sure enough it's -92. That's another way to check it. A bunch of different ways to check that. Alright, so that's that. So end behavior. End behavior. Anyone know why this guy's here? We'll talk about that in class. But end behavior refers to what happens to the function as x approaches infinity or -infinity. Okay, so graph and describe the end behavior. So I'm going to just sketch this graph. If you type this in your calculator and hit zoom 6, we'll do one together in the calculator. I have x to the 4th minus 4x squared plus x. And I'm going to hit zoom 6 just because it was in a weird format. Okay, so there's kind of my graph. Looks like that. Something like this. Okay. Now, basically, just think of it this way. As x is going this way, what is y doing? Hopefully you see that as x is going towards -infinity, because that's the way I'm pointing that way, x is negative forever, this graph will go on forever in the up direction, right? So I can say y, or f of x, the function, is going to infinity. If I look in the other direction, as x goes forever that way, if I keep going that way, my graph is going up forever. So again, as x goes to positive infinity to the right, my function is going up. So whenever you're dealing with the function, it's up or down, x is left or right. Okay, why don't you guys plug this in to your calculator and look at the graph. I'm going to just sketch what it kind of looks like. It looks something like this. Okay, so again, I look at -infinity. So as x goes this way, this graph is going down. So as x goes to -infinity, my function is also going to -infinity. As x goes off to infinity to the right, my graph is going up. So as x goes to infinity to the right, my graph is going up to infinity forever. So it's going to positive infinity. So again, you look in the x direction you want and see if it's going up or down. Alright, so here are the following end behaviors. Again, you don't have to memorize these, you could just look at it, but If you have an even graph, so like the first one was an even graph, notice how they're both going up, or they'd both be going down. So if the first coefficient's positive and it's even, you have infinity and infinity. That was like part A. They both go to infinity. But if you have the same thing and the first coefficient's negative, it flips the graph over. So if I flipped part A over, they both would be going down at the end. So it'd be negative infinity and negative infinity. Okay, this one is like letter B. If I have a coefficient that's positive, if you go to negative infinity, you go to negative infinity in the y direction, and in the x direction, you go to positive infinity. If for some reason for B we put a negative sign in the front, it would flip this over and this back up, and so we would flip the symbol here. This would be going up to positive infinity, this would be going to negative. Again, do not need to memorize this though, just look at the graph. Look at your graph, it tells you. Okay, and finally, graph all the important information. So, we already had a sketch of this graph because we did this one up above in part B, but I'm going to make a bigger sketch. It is key that you do everything that you need to for this graph. I need to describe its end behavior first. Let's just get that out of the way. As x goes off to negative infinity, which we did, f of x goes off to negative infinity. As it goes to the left, it goes down. As it goes to the right, the graph goes up, which is also positive infinity. Alright, it says your graph should contain all the important information: y-intercept, x-intercepts, and all local maxes and mins. Alright, so I need to find basically this point, this point, this point, this point, and that's it, because there's nothing else there. Okay, so let's do that on the calculator. Again, you need to type this in, x to the third. You might already have it in there, plus 2x squared minus x plus 3. And we graph it. There it is. Now you have to be careful because there is a minimum here and a y-intercept here. The easiest one to get is the y-intercept. You could pretty much just hit the trace button or look at your table. When you hit the trace button, it gives you the y-intercept. When x is 0, y is 3, because that's where the trace always starts, is at x is 0. So right away we have a 0, 3. Now if it's a nice point, obviously leave it as that. But if it has decimals, round to the nearest thousandth unless I state otherwise. Okay? So let's find the other points. We have an intercept of x here, so that means we need our y2 to be 0. I have to do that. Again, this is calculator work. I'm going to go through this just so you have another thing, but try it on your own first to get all the points. So second trace, 5. I hit down to get onto the other line. Again, you need y2 to be 0 to do this. Hit enter a couple times, and you get negative 2.757, comma 0. Negative 2.757, comma 0. So this point here is negative 2.757, comma 0. And always check, guys, that the y-intercept, sometimes it's going to be sneaky and you won't see that there's two things there. But you have to be careful. They're really close together. You have to check to see if there's a maximum that's different. Always check to see if they're the same or different. So let's do the max and min. Let's do the max and min. Second trace, let's do the max first. Enter, and again, for maximum you have to be to the left of it, which we are. Go over past it to the right, and then move your cursor to the middle. You have to bound it and then hit enter. You should get negative 1.549 and 5.631. Negative 1.549, comma 5.631. And now we need the min. So we need the last piece. Second trace, 3 for a minimum. I need to be to the left of the min, which I am. You can hit enter right here. To the right, hit enter, and then the min. And sure enough, that minimum is not 0, 3. So you do need that other point. 0.215 and 2.887. So this minimum is 0.215 comma 2.887. And this is what I require. The sketch, which should look very similar to the graph, spacing, obviously you don't have to mark anything. Just give me the important points. The y-intercept, wherever it crosses an axis, and mins and maxes. And then the end behavior. Alright, so that is 6.2.